Hi everyone, and welcome to another video. Now there's a subject I've been wanting to do for a while, and that's Wireshark. Now I know some of you have also wanted me to do some videos on this, so today's your lucky day. I'm going to have a look at Wireshark, and this will be over a few episodes though, because there's just too much to do in one go. So we'll make a start and see how we go. Okay, I've got Wireshark open here on this Linux box. Now it's an old version, but that doesn't matter for today's purpose. It'll be just fine. So what you've got is your list of network interfaces here, and obviously the one I want to use is Ethernet 0. Now technically speaking, Wireshark isn't a capture tool, it's an analysis tool, but you can start a capture from it. So if I start a capture up here, this being a nice quiet Linux box, it's not pouring out data non-stop. So it's very quiet on my network here. You'll see stuff come in, but we'll get back to that. What I want to point out is while that's capturing, in the temporary directory, there's a file getting built called Wireshark. This is happening right now while it's doing that. So if you look at that again, it'll probably get bigger. See? It was 1.6K, now it's 1.9. That'll get bigger. So just keep that in mind that while I'm capturing, this temp file will get large. So if you want to see how much space it's taken so far, just look at your temp file. Now, as I mentioned, Wireshark isn't actually doing the capturing. There's a process called dump cap. Okay, and if we look, there it is. So dump cap is what's actually making this file. It's just controlled by Wireshark. So if I stop Wireshark, there'll be no dump cap anymore. Okay, so Wireshark technically isn't doing the capturing, but it's working pretty close with the thing that is. Okay, so anyway, I've just done a bit of a capture. Not much, just a few packets. So we'll have a look what's floating around on my network. First of all, you've got up the top here all the frames, obviously, 1, 2, 3, 4, and so on. Everything you've got sort of happening comes in there. Down the bottom, I'll just start with frame 1. Down the bottom, we have this first row here, which just tells you about the frame that we've captured. Okay, so the arrival time, when I did the capture, time from the previous capture, well, it's the first one, so maybe that's a bad example. Pick one down here. The time since the previous capture, the time since the previous displayed, which I'll get to later on, and just some info basically on how it came to get that capture. Okay, so that's the first line. The second line is layer 2 of the OSI model. It's the frame that we're talking about, and it's an Ethernet frame. So you can see if it's a broadcast destination address, the source was some TP link. Okay, we've got the MAC addresses for the source and destination. They're layer 2 addresses. Okay, they're the MAC addresses. What you've also got is the type. In this case, it's an ARP, and that's how this column here, the protocol, tells you what's going through here. So it looks at that for you to put it up here nice and convenient. So that's all the layer 2 stuff. Basically, the source MAC, the destination MAC, and the ether type, the type of payload that it contains. So the next one down is layer 3, and for this we have some IP addresses. Probably wasn't the best example. I'll use NTP. Yeah, that's a better example. So as you saw over here, we've got network time protocol, okay, which we'll get to down here. The first line shows you when it was captured, the time deltas and stuff, as I just said. Second one, destination MAC, source MAC, and what it is. Now this says the payload is IPv4. Okay, so when we go to the next line here, which is the payload of that one, we see it is indeed IPv4. And at this stage, we now have some IP addresses. So you got your source address, destination address, or your flags here, like you don't defragment, don't fragment or more fragment, IP stuff. This is layer 3. So the third row here is layer 3. In there, it has a payload which is layer 4. So we go up to layer 4 now, and we can see that it's UDP. Okay? In fact, somewhere in here, it would say, this. Protocol 17, which means UDP. Okay, so that now tells us what the next one is. So here we are with UDP. We have a source port. We have a destination port. So this is UDP now, layer 4. See how it's on the 4th line? And we also have the higher up protocol here, which is the actual NTP. Okay, so you see all the stuff particular to that protocol. So basically that's what it's about. If you look at, what else have we got here? NFS, right? Network file system, same sort of thing. First line tells you when it was captured. Second line, source MAC, destination MAC, and the type of payload, IPv4. Next one is that IPv4. And we have the source address, destination address, our flags, and what it contains. So when we go to, here it is, protocol 6, which is TCP. So we know that the fourth layer is going to be TCP, as opposed to UDP a second ago. So for TCP, we see the stuff relevant to TCP. There it is, all your flags, window size, all the good stuff. Okay. Now after that, we have some higher level stuff. Now this is particular to the protocol, as I said. This is if you're looking for something in particular. Okay, so there's all the things that are particular to NFS. Okay, beautiful. Okay, I've just started a new capture, and you can see a couple of things here, like IGMP, LLDP, and PIM. Just their details are down here, as I said. Now, if I start Firefox, for instance, just with a blank page, you know there's going to be some traffic. Okay. Now, I'm not actually doing anything except starting a blank Firefox page, and now we can see traffic flows all over the place. Okay, so you can be pretty sure all that's related to Firefox since there was nothing there before. So where do you start? It can seem a little bit daunting, but it really depends what you're looking for. So if I just go back to the start of that, you can see the first bits of what I had. You can tell right about here is where I started. So let's look at that. That's this IP address here, and the destination is Google's DNS, because that's what I've got it set as. And here it says DNS. But I'm going to just drive the fact home and go through this again. The second line here is your Ethernet layer, layer 2. So again, source MAC, destination MAC, and the type of payload, which is IPv4. So the next one is IPv4. Okay, it has the stuff to do with IP, the IP addresses and that, and it says what protocol's in it. It's protocol 17, which is UDP. So we know the next one is UDP, and there it is. Okay. And the payload, we know, we interpret port 53 as DNS. So, you know, DNS did a query. We can look into that and see what did it ask for? Well, there you go. It asked for detectportalfirefox.com, which in this info column, you get a brief breakdown of what it is. It helps you out, so you don't have to go into this all the time. Okay, so we could have looked at that right there, but, you know, that's how it's built as far as the packet's concerned. So anyway, there was a bit of DNS out, a bit of DNS coming back in, and then we can see the green one. It's made green for you for HTTP, and that's the thing about Wireshark. It's an analysis tool, so it's, you know, colours it a bit for you to try and make it easy. So you can see HTTP here. The flags. If you go to the TCP flags, because it's the first one, it's a sync packet, okay, which is also here in this little square bracket. And following that, when you set up a TCP session, you know, you've got the three-way handshake. You'll have a SYN and an ACK. There they are, as shown here. And the last one's an ACK. And of course, the session's open at that time. So the next thing that happened was this computer went to get this location, this address. So we can look into that, because we're not at this moment too concerned about the IP layer and the fact that it's using TCP. We want to look at what's going on with HTTP, and we can just go into that here. We can see that there's a GET command. We can see what it looked for, this success text, okay, which again, it shows you up here for you. But you can see all the stuff basically that's going through. So this computer sent all this stuff out basically for that GET request. Now, there's probably more HTTP, as in different sessions, but let's say I want to look at everything to do with this particular session. Now, you're probably aware that TCP is session-based. As you saw with the SYN-SYN-ACK ACK, it builds a session from that. So what we can do is just right-click on this and follow that TCP stream, and we'll get a filter now. I'll come back to that display in a minute, but we get a filter where it shows you TCP.stream equals 2. So basically it was the third, because it starts at 0, TCP stream in the capture. So we see all the packets relevant to that stream. And if you do that, it does show you in another window here the actual data in those packets. So the red came from this computer and the blue is what came back. So it's a quick, easy way to see what's going on. And to clear that filter, just close the filter over here. So you can see stuff that went on. What else? If you want to have a quick look at DNS, I can tell you right now the display filter is simply DNS. So we can have a look at just all the DNS packets that went through. Okay. Now I know that the display filter for DNS is simply DNS. But if you didn't know, or some other protocol you're looking for, you could just go down here to the bit that you're interested in. So we're not interested in the IP part or the UDP part, we're interested in the part to show the DNS. Just right click on that and apply as filter selected. Now whatever you selected will be up here to show. So I'll give you a better example. Let's pick something a little trickier. We'll go back to that HTTP, right? This GET packet here. The one that we saw was HTTP GET. Now there's a lot of things going on in this that you might want to filter by. You may want to filter by that source MAC address for any packets coming in from that MAC address. You may want to filter for the IP address, wherever that's hiding, down here. You may want to filter for the port. Okay, you might want to filter for anything on port 80. It might not be HTTP in the payload. You might just want to filter port 80. If you want to filter for destination port 80, just right click that, add as filter selected. And there it is, tcp.dst port equals 80. Now again, I know that off by heart because it's a common one, but if you didn't know it, you can just select what you're looking for here. Okay, now it doesn't have to be HTTP to fall into that filter, it just has to be TCP dest port 80. But let's say we wanted to get tricky and find out just the files that it's doing a GET function for. Well, forget the layer 3, we're going to have to go up a bit to the actual HTTP. And you can see down here, we've got request method GET, we've got the URI and all the rest. So what we want is things that have GET with them. So just right click it, apply as filter, selected. Now this, I didn't remember off by heart. HTTP request method is GET. I mean, it makes sense, but I don't remember that. So any HTTP GET requests will come up. Apparently there was only one, so it wasn't probably the best example. But you can start to see how we're doing this here. Okay, I'll just start another capture up here. Okay, so what do we see? Should just be some background stuff. Yeah, a bit of this, bit of that. IGMP, nothing special, right? Now if I go to Firefox and start up google.com, you can see a whole bunch of stuff came in here. Still only up to a couple of hundred frames, but really it's starting to get big now. You saw it just flood in like that. If we wanted to look for something in particular, like let's say DNS, you can already see it popping out at you here, you could just filter it, as I said, with DNS, okay? But let's say I've still got that capturing. Oh, by the way, this button here makes it scroll in live time here. Let's say I open VLC and go to network streams. Now straight away as those stream information's coming in, you can see up here I've got a lot of SAP messages now. That's because VLC would have joined that multicast group. So at the start of them, there's an IGMP message, but it's messy. So just put in a filter for IGMP and you'll see it. I see it here. This machine joined a whole bunch of IGMP groups, okay? So, we filter it. The problem is, it's still capturing everything. Now, if I actually start one of those streams, just start something from the camera here, okay, and I don't particularly need to see that. Just look at what's coming in. You see a lot of MPEG transport stream because, video's coming in here. And if you look here, the packets are flying in, okay, there's heaps of them. So remember I said that's making a temporary file. If we look at the file now that's being made, you can see it's up to 11 meg, okay? Look at that again, it's up to 13. Now if you had some serious data coming in here, that would really get big and you'd have to keep an eye on it. Okay, I stopped it and it was up to 21 meg. So we're working with this file, because I haven't saved it yet, so we're working with this file in the temp directory. Okay, and what you can see, of course, is a lot of MPEG transport stream, okay, for that video. I've stopped the capture, so we can just work with it now. So in there somewhere is some DNS. So how do I find the DNS? Well, we know they can just do DNS, okay? And there's all the DNS. Now, that's not much. You can see it's really not that many frames for DNS in regards to a 21 meg file. And these can get massive, by the way, if you're capturing something big. But the thing is, it's a bit of a waste to be making this file when we're only after, let's say we're only after DNS. So this filter up here is actually a display filter. Okay, it just manipulates the display and filters what's already been captured. But if we're only interested in DNS, then we can use something like the port. Okay, so you can use, we know that's UDP, and we know it's port 53. So when we do a capture, down here you can have a capture filter. And here you can say UDP port 53. Okay, I don't want to save the previous one. Okay, now I've got that capturing just UDP port 53. Not necessarily DNS, but we know DNS uses that. So I'm capturing there. If I go back to, let's say Google, there you can see DNS, and only DNS, okay? So if we look at the temp file for that, it's going to be tiny, okay? 2.4K. Now, I still, yes, have I got it going? Yes, the wind's just stopped. I didn't think it was moving. But I've still got video coming into this machine, okay, and that's a huge amount of data compared to DNS, okay, but we're not capturing it because for the capture, I'm not interested in video, and I could have other things going on like, you know, whatever, file shares or bloody whatever. So a capture filter is great for when you know specifically what you're after, and you can filter a lot of things out while you're capturing it, so you don't have to build up a massive file. So that's the capture filter. And one thing about the capture filter is it's the same format as TCP dump. So if I go to a console, if I just do TCP dump, which if you're not aware is also a capture program, this will just display it onto the screen unless I save it to a file. So if I just do TCP dump now, it'll show everything because I've got that video going. Okay? TCP dump is probably a different subject, but it works slightly differently. After the IP address, it uses a dot instead of a colon to represent the port. Okay? So this is port 20,000. But the point is, TCP dump can also do filters. So you can go TCP dump UDP port 53. So now, that will only show you DNS. Exactly the same as a capture filter on Wireshark. So again, UDP port 53. And yes. And here it is. So not much DNS happening. But if it was, there we go. You can see they have the same things. Okay, the same things just came in to Wireshark as came in on TCP dump. Just a different tool for different purposes. But the point is, if you figure out what capture filter you want by going through here and finding what port number you want and then going, okay, we've got it, and then you make a capture filter on here, this capture filter, which is a different format to the display filter, of course, this capture filter is the same format as the TCP dump filter. Okay? These two are the same format. Okay. So that's roughly how we capture things. Now let's say I didn't have a capture filter on and I just capture everything. Okay? I've still got the video running here, so it's smashing it with all sorts of stuff here. You go into Google, you go into whatever, and you think there's DNS in there somewhere. Stop your capture and look for DNS. Is it there? Yes, it is. So let's say I want to save this, but I'm not interested in saving all this, because how big is that file? Okay, it's 4 meg. And really, let's say I'm only interested in 4 packets of it. So I've just set up a display filter up here. That's what this is, a display filter. So what I can do is, instead of saving the whole capture, I can just save specified packets, and I can just say the displayed packets. So all packets that are currently displayed after that display filter. And you see there's 4 of them. Okay, so you can say DNS only, and now I've just saved DNS file. I still haven't saved the whole thing. See, that's why that temp file's still there, because I might want to undo the filter and save something else. So now, when I open that DNS file, you can see up here DNS only that I just saved. I've just opened it up, and all I have are the 4 packets that I was interested in. Okay, so if you're looking for something particular and you're not sure and you have to capture everything, once you've found it with your display filter, just export only the packets you're interested in. Okay, so that's how you do some capturing and look for what you want to find. Now, I don't have anything really that exciting on my network here to look for, but it depends what you're doing. Oh, look at that camera. So if I stop the camera, you can see that the video stopped. Now we've still got a lot of SAP. If I close VLC down, the SAP stuff will stop. You can see that it did the IGMP leave message, okay, when I close it, so it's no longer being forwarded the SAP multicast, and we're just back to background noise. And if I shut Firefox down, it'll get even quieter. A couple of Finacs for whatever sessions Firefox just had open, and that's it. So that's how you do a capture. The main thing to remember is, if you're capturing something big, try and narrow it down at the capture filter so that you're not just wasting your space and possibly crashing. If you fill up a laptop with gigabytes of stuff and you don't have the space left, it might crash. I have seen people do that. But once you've got it on here, you can really get creative with these display filters. Now let's say I want to see a couple of things. Let's say I want ARP and PIM, but I don't want LLDP, I don't want IGMP, I just want ARP, or you can use these bars here, ARP or PIM. And you see how that was red here? That means my filter isn't right. Once it becomes right and you've got something it can figure out, then you can do it. So now all I'll see in the display filter is ARP or PIM. Okay, you can also, I think you can do OR, but I never use it. Yeah, you can use OR. Again, I just use that. And you can get creative with brackets and things and do, and as well, and other things, like source MAC address might be whatever you want. So you can get creative with these filters. You can get really creative, and I might go through some more of those in the next video. But for now, I think I'll leave that there, because no doubt there'll be some questions, and I'll try and address them in the next video when I dive a bit deeper into this. Okay, look, going through Wireshark and presenting it from scratch is pretty tricky, because there's a lot of different components to it that I guess I take for granted, but it's hard to know where to start. So I just wanted to start with a simple capture. Now, I kind of assume that you know a bit about the OSI model. If you don't, then you should. Okay, fucking learn it, and then Wireshark will make a lot more sense. What I'll do in the future is look into more specific examples, most probably with wireless, because that's what I use it a lot for. But if you've got any questions on how to use it for something you're using, be quick and send me a question, and I'll see if I can do a video on that with Wireshark. But the main thing is, if you're capturing a lot of data, something that's big, just to find something small, try and get a capture filter on there, otherwise you'll be wasting your space on your computer. And if you do, because you don't know what exactly you're looking for, once you find it with a display filter, just export those displayed frames out, so then at least the file that you've saved won't have to be big. So anyway, I'll leave that there, and it's far from over though. There's plenty more on Wireshark, so there'll be an upcoming video that follows up from this one. So until then, happy capturing.